For my 7th standard on rotational dynamics, I did the practice problem 5.13 in chapter 5, circular motion. This problem says that the London Eye, a Ferris wheel on the bank of the Thames, has a radius of 67.5 meters. So the London Eye is a Ferris wheel, and I try to draw the Ferris wheel right there. And it says at its cruising angular speed, it takes 30 minutes to make one complete revolution. Suppose that it takes 20 seconds to bring the wheel from rest to its cruising speed, and the angular acceleration is constant during the startup. It wants me to find the angular acceleration during startup, and then it wants me to find the angular displacement of the wheel during startup. So first, since it says that it takes the wheels 30 minutes to complete one revolution, so I had one revolution per 30 minutes, and I want to convert that to radians per second so that I can find my angular acceleration. So I did 1 minute equals 60 seconds, multiply that, and then I did multiply by 2 pi radians per revolution, because this is the circumference of a circle, which give me rads. Revolutions canceled, and then minutes cancel. I plugged in 2 pi divided by 60 seconds times 30 minutes. And then 2 pi divided by these two numbers gives me the outcome of 0.0035 radians per second. And since now I have it in radians per second, I can find my angular acceleration. And we know that the angular acceleration is the rate of change of the angular velocity. So we can calculate the angular acceleration by finding the angular acceleration for the time interval. So for this equation, I have alpha equals omega final minus omega initial divided by t final minus t initial. Plugged in my numbers. My initial was set to be 0, and then I had what's left. Plugged that in the calculator, and I came out with my angular acceleration is 1.7 times 10 to the negative 4 radians per second squared. And then to find my angular displacement during startup, this is my equation. I have delta theta equals 1/2 of omega final times 1/2 times omega final minus omega initial times delta t. So I plugged in my numbers, 1/2, since I found my my radians per second, which is my final omega. I added to my initial, multiplied by delta t, and I came out with the angular displacement of the wheel during the startup is 0.035 radians. And that is problem 5.3, the practice problem 5.3 of chapter 5 on circular motion.